You're welcome to another lesson on my YouTube channel. Today I'll be dealing with a question that shows the interrelationship between kinetic energy, electric force, as well as some other important terms like the electric field itself. Here is the question in consideration. An electron of kinetic energy 1.25 times 10 raised to minus 17 joule moves a distance of this into a perpendicular electric field configuration. If the strength of the electric field is this, calculate the deflection suffered by the electron. So the solution goes thus. First of all, we take down all the important parameters stated. We are told the kinetic energy is 1.25 times 10 raised to minus 17 joules. Move the distance of 5.0 meter into a perpendicular electric field configuration. If the strength of the electric field is stated as 3.204 Newton per coulomb. So what we have here now is that we need to express this in form of a diagram. What does the question say again? We review that an electron of kinetic energy this moves a distance this into a perpendicular electric field configuration. That is, if the electron was moving like this, definitely the electric field was moving in perpendicular direction. So let's assume it's moving like this and that the electric field is moving like this. Definitely, if an electron intended to move like this and there's a forceful electric field moving in this direction that is perpendicular, the electric field definitely will not end up like this. It will end up moving somewhere like this. You can see that it's still, just like the effect of the wind, there is a push. So this is the deflection. Let's call this Y deflection. So just like similar to projectile motion, we can start by saying Y is equal to ut plus half at square. Where did I get this formula from? Formula for distance. Y is a form of distance, so ut plus half at square. So this is this is one of the effective projectile motion, you understand, formula. So there we can use the interrelation of formulas in physics. Now if we say this is the deflection, we can quickly note that u is 0. The initial velocity is 0. So y will be written as, why is the initial velocity 0? Definitely the electron would have started moving from rest. So y will now be half at square. So this is the formula we use to find the deflection, but we don't know acceleration, we don't know time. That is why we are given all these other parameters in order to find these two. So we'll go ahead by starting with saying, okay, force. If we recall, force is equal to QE, electric field times charge, and normal force is also equal to MA. So let's relate these two. MA, we can say MA equal to what? QE. So A will definitely be what? QE over M. Let's call this equation 2. I will call this equation 1. So definitely we'll use this later in 1. So let's look for ways to also find T. Now we recall that from the normal distance formula, the speed is equal to distance over time, definitely. So time is equal to what? Distance over velocity or speed. Let's say speed now. Let's call this equation 3. We also use this as T in this place. So let's substitute equation 2 and 3 into what? 1. So we now have that see equation 1 up there, y equal to half what? At square. That's y equal to half at square. I've written that again. If we put equation 2 here, we now have y 2 and 3 here. We have y equal to half. A is q e over m. Yt is d over v. We now square it. So at the end of the day, we'll arrive at this formula. Y as half QED square over MV square. QED square over MV square. So now the next thing we need to do is that from our formula, we go back to parameters listed. We can utilize D now because D is in our formula. We can utilize E because E is there. D and E they are here, and definitely we know the charge of an electron 1.6 times 10 to the power minus 19. But we are left with this. We can easily relate this to the kinetic energy given. Normally kinetic energy equals to half mv square, right? So mv square definitely will be 2 ke. If you look at it, if you cross multiply properly, yeah, so mv square on its own now will be 2ke. So substitute this, call this equation, let's call it 5, so that we'll call this 4. So if I say substitute 5 into 4, that will now make us to say y will equal to half QED square over, instead of mv square now we'll put what, 2ke. So at the end of the day, we can probably write y as 1 over 2 times 2, 4, QED square over what, ke. Now we can impute all we know, all the parameters we know. That's times 1.6 times 10 to the power minus 19, that's charge. Then from our question, the E is given as 3.204. 3.204. Then the distance we had in question was 5 times 5 square over ke is given at 1.25 times 10 to the power minus 17. 1.25 times 10 to the power minus 17. So after doing the total of this calculation, we arrive at a very succinct answer, 0.256 meter. That is the deflection. I hope you learned a lot. I would encourage you to subscribe and follow along the lessons I'll be releasing. Thank you for watching.